Welcome everyone. So my name's Andrew Forward. You can find me on Twitter at aforward or at Gmail, and I work for CrossFit, so you could email me there as well at andrew@crossfit.com. Thanks to the organizing committee of WebCamp Zagreb. It's been lovely so far, and I've got to visit your lovely city. And now let's talk about time travel and changing history. So Git is complicated. There are concepts that are known as threshold concepts or threshold knowledge, where once you cross a certain level of understanding, that changes your whole perception of the concept itself. And it actually makes it harder to explain to others that aren't there about why it's that way. So my goal today is just give you a little nudge, a little push towards getting a bit closer to the threshold edge to make Git a little bit less complicated. Take this as a warning. I'm not responsible for any loss or damage you might suffer from following this journey to Git enlightenment. It's all on you. In a perfect world, we obviously solve things perfectly. In my imperfect world, I might find a bug mid-feature. I might take a break from a feature and clean up some code. I might need help from some people, need to push a temporary change. I might have to chase down a rabbit, trying a bunch of things, a bunch of different commits, false starts. And this might be in a bunch of terribly worded, terribly formed commits. I might need to share the code. And reality is messy. And there's nothing wrong with changing our Git commit history to tell a more compelling story about the intention of the changes, not the actual journey that we took. So git rebase, and there are a few other similar commands, allow us to change what actually happened. And the purists are going to complain that the repository is no longer a true reflection of what actually happened, and I agree, but I think this is a good thing. I think that Git allows us to clean up our disorganized self and our disorganized code, and we alter history all the time. The first draft of this talk, the draft from yesterday, from a week ago, from a month ago, is different than what I'm presenting now. And all other mediums are highly edited and tailored to the intended audience to try and deliver something that's clear and concise. We want to remove our missteps. We want to better communicate our intent. And this benefits the audience. And that audience might actually be us in a few weeks or a few months when we have to go back and revisit this code, or also your colleagues. So Git's a distributed source code repository. So unlike our centralized versions like Subversion and that, every copy of a Git repo is itself a Git repository, and every copy can behave like a server or like a client. So you can push a remote server, and then you can pull into your local client. And most people are going to be using it as a centralized repository, but it's not. So we need to consider two falsehoods in what I just said. So the first is you don't really pull code into your local code. You actually fetch it from the remote repository into a local copy of the remote code that allows us to do what feels like remote operations, but locally on our local copy. So we now have our local copy, but we have our local copy of the remote code, and then we have the actual remote server with the remote origin code. And if we look into our Git commit history, into our Git configs, you'll see that origin is actually just a label. It's not a constant. It just refers to where our code comes from. You might also notice that I'm using the word main here. So words matter. Yeah, master is an unfortunate term that we use in the tech industry for meaning several things. And it's the default name for your primary branch. You might not always be able to change it or get away from it, but if you can, try, because there are much better words with fewer emotional and historical baggage. And so that source, that origin, just refers to some remote repository that exists. Here's a theoretical repository in GitHub. And then now we can reference that with our main branch and our feature awesome branch. So pull, we might be using, might be familiar with, might know what it actually does. But what it's doing behind the scenes is it's going to fetch code into our local remote copy using a git fetch. And then we're going to merge that local origin code, so that local origin remote code, into our actual local code. The second falsehood is that you're not really pulling from the server, you're just pulling from a remote server. It is a decentralized repository. And so we mostly push and fetch from the server, but we could have multiple, so we need to give them each unique names. The default's origin. But another popular one used for open source contribution is upstream. we're now going to consider Amy. Amy is a developer getting back from a very unplugged holiday. First thing back, she wants to forcibly get the latest code from origin. She's going to enter into the main branch. She's going to fetch the code from the origin server, and she's going to do a hard reset against that local main branch. So in this case, it's probably overkill. A pull might have been sufficient, but Amy knows that she has no local changes she cares about. She wants to start fresh. Other reasons to do a hard refresh or reset could be that you're lost in the Git universe and you need to get back to a known stable place, which is your remote server. Now Amy's ready to work on her jump to conclusions feature. So she's going to create a new branch. She's going to immediately tell that origin server, that remote server, about this new branch, so that way she can push and fetch without always having to refer to it as feature jumps. As of 3 months ago, Git has released 2 commands to sort of replace or change out what checkout does. So checkout serves 2 purposes. One is to hop into different branches, and they've now introduced a switch command. And the other is to undo local changes, and Git has put in a restore. I'm going to stick with checkout because, again, this is only months old, but just know that the change is coming. So Amy makes some great progress on the feature, trying to follow the mantra of making the hard change easy, and then making the easy change one small commit at a time. But she was in a rush with that last commit. She wanted to get to lunch. So on her way back, she realized that she probably has a better name for the doing stuff message. So she's going to amend that last commit, changing the text to hard change. And now we've diverged. Now the dreaded I have diverged from my origin. So even changing the description of a commit will change the commit itself. So our local feature branch is now different from our local copy of the origin remote branch. It's a lot to swallow, but again, remember that status is not a remote network operation. We could still be behind from what's on the actual remote server. So we want to make sure that we are always fetching all the time. And this is why git fetch is something that we need to be doing all the time to make sure that our non-networked operations are actually against what is the latest and greatest on our remote server. So this divergence makes sense because we changed the commit, we amended it, and so we're going to now push it with a little bit of force. And we're going to use the with lease. With lease just helps us ensure that if other people are on our branch messing around, that we don't accidentally overwrite their work. And here we've we've changed the commit C into a D. This is our branch, so we're going to forcibly push it over, and this is going to overwrite what's on the server with our better code, which is ABD. Amy then also notices that she forgot to commit a few files. She's going to use the capital-A command to add all changes locally, and then she's going to amend the commit again, but this time she doesn't need to change the message, so she can do a no edit. But the code isn't really flowing. It's not really reading nicely as what she wants. She wants to make the hard change easy and then make the easy change. So now we're going to get into rebase. And here, Amy just wants to reorder the commits to tell a better story of the progression of the feature. And we can do this with the -I for interactive rebase. Once the commits are in a better logical order, as opposed to the original disorganized order, sort of the time-based order, we're ready to push that diverged local branch. Again, this is our branch, our feature. We're the only ones working on it. And so we are going to forcibly, with lease, push these back into the origin server. Amy leaves for the day. She's back tomorrow to finish the work. Her teammate Bob was also working, and he pushed new code into the main branch. So we're going to pull that work into our work. So first we need to fetch from the server. That will get our local remote copy up to date. And then we're going to rebase against that origin main branch. This origin main is the local copy of the main branch that's stored in the server, just like our feature jumps has an origin feature jumps stored locally. So visually, we can see this as yesterday. We had some commits. We're working in a team, so Bob is going to push a few commits. His PR gets pushed into the main branch. When we actually do the rebase, we're going to detach our local commits on our branch, so our X and Y, and we're going to just reattach them at the end. The output that Git gives you actually tries to relay this information. So it's just saying, by the way, I replayed the head back to where we started to diverge. I pulled in the latest changes, and then I'm going to reapply in the right order. So I'm going to make the easy change, and then I'm going to make the hard change easy, and then make the easy change. With interactive rebase, you can also edit individual commits. So this process is similar to adding debug breakpoints into your code, and then as you're running your code, you're stepping in. You can then change what actually happened. You can edit files, add new files, remove files. And where the applying the commits will stop mid-process and allow you to make those changes. So this is a great way to fix up local errors in your branch, a great way to have interim versions of the code that you know is going to need to change later, and to make it more perfect. And when you're ready, you can continue on with the rebase. And this is where rebase really gets its bad name, because you are changing history if there are others that are pushing history in there as well. So on the left, we have our tiny little amended commit, but we forgot to push the change. And someone else, maybe even us, maybe we have multiple copies of our code lying around, we push code to the remote branch based off that older C. So now we've diverged at the commit B. So if we try to do a rebase now, then we're actually pulling in that old, obsolete C, pulling those changes from the remote server, then we're applying our better version of C, which is D, and then our changes after that. And this is where you get into a mess. So if ever you're mid-rebase, or when your repository catches fire and there's some sort of strange merge conflict, warnings, empty commits, or things that aren't proceeding as you had liked, you can always abort out of it. And then, sometimes I'll even get a little bit too overeager with changing history, and abort is what really helps to get me back to a known state. Now, Amy finds a bug in some of Bob's code. He's not available, and so she's going to go ahead and fix the issue locally. So she's going to add the fix to the file. She's going to commit off by one error. As it's unrelated to her work, Amy is in the habit of automatically moving that unrelated change to the top of her local commit history. And as she likes to do that, this is good for just this such occasion, because it turns out that the bug is affecting a lot of people, and the changes need to be out today. Amy's feature branch, however, is filled with stuff that is not ready to go out to production. So because she isolated the bug fix into a separate commit, because she put it next in line, we're actually able to go back into our main branch. We can pull in the latest and greatest main code, which will do a fetch and a merge. We're going to check out this off by one error that Bob unfortunately put into the code. We're going to then cherry pick out our commit with the commit hash, and then we'll push that through, we'll get that code in. Back when I go back to my feature branch, I can just do the rebase back to the 6, and I can just throw that commit out. It doesn't actually throw the commit out, it just kind of removes it from my knowledge of this feature branch, and I'm going to force that with lease. So now when I do a fetch and a rebase, I'm going to get that bug fix command. My world is the same. Mains branch has that much needed fix in it, and we're all good to continue working. So your git commit history should tell the story as the code evolved to deliver that great feature, fix the awesome bug, or clean up the code. The reality, unfortunately, is that you're going to take 8 missteps. You're going to fat finger something. You're going to intersperse clean code with random bug fixes. And so taking that poorly constructed story and editing it into a clear and concise summary will help your future self and will help your colleagues when you return back to the code later. So let's qualify this with an example. So we recently introduced Apple Pay at our company, and here is an isolated code snippet of the Apple Pay session to get it going. And there's nothing sensitive in there, but you will notice that it's full of really bad code. We've got hard-coded everywhere. We've got constants. This isn't really suitable for a git commit, but I committed it anyways. Why? Because I needed to get it working with other JavaScript code, with other PHP code. I needed to make sure that I had several other factors working, and I knew I was going to come back and fix this code up later. And so slowly but surely, as the code was reworked into the final production-ready state, this commit eventually evolved into that production-ready code. Refactoring can take on several meanings, but here I'm talking about the small behavioral changes. It should preserve the intent of the system, and it should be done incrementally and in safe steps. So refactoring is not an excuse to go back and fix those to-dos like we had with the Apple Pay example. But again, the quote from Kent Beck that I've been using over and over again is that we want to make the hard change easy and then make the easy change. And so my interpretation of this is that you want to refactor, rework, re-architect your system before you try and implement the change. So in that perfect world, you know exactly what that making it hard change easy would be. You know exactly what the steps should be, but in reality, you don't really know. In reality, it's a little bit harder to do that. So with Git Rebase, that allows us to construct that near perfect example using perfect hindsight to let your code changes flow from a coherent set of refactorings into actually then turning on the feature. So this is the beautified refactored code. It was not apparent at first, but we were able to extract a PayPal method into a more generic wallet method. And this was discovered after the fact, after I'd created the duplicate code. But again, the story that I painted to my colleagues was that, of course, I knew from the beginning that this should be refactored into a wallet. So now I make the easy change. And the easy change is a one-liner to support Apple Pay wallet. We saw it with Amy's example, move unrelated fixes to the top. Unrelated fixes to the top will ensure that any related fixes come afterwards, so you could, at any time, cherry pick them out into separate pull requests and get them into your main trunk sooner. So as another example, working on some of our chef code, there was a bug that was found. This is a JavaScript example. So when I was working with the Apple Pay, we found a JavaScript example, and so here I committed it separately. This was found several days into the Apple Pay work, but then I moved it to the top of the commit list. That way, if this was a much-needed code change, I could easily cherry pick it out without having all of that other code interspersed. There actually was quite buggy for this pull request. There was another small bug in some uncatchable code, but it got caught in my dev environment, so we pushed that through again, moving it to the top. So how do you know the top? You can use this command. I'm not going to show up for very long because I just go to GitHub and I just ask it in my pull request how many commits are there. And moving it to the top is literally just moving it to the top. So here is my interactive rebase. I'm going to find the lines of code that I want, and I'm going to move them to the top. So pull requests and git commit logs, they act as a great history for the evolution of the system. So by organizing your commits by first addressing the bugs, if any, then addressing any refactorings, which can include moving code or improving the code, then providing the functionality of your features, and then finally enabling those features, it's going to tell a much more compelling story about how you made the hard change easy, and then you made the easy change. And Rebase is the tool that I use to help accomplish that. It allows me to edit messages. It allows me to reorder commits. It allows me to fix committed code. I can combine commits, squash them down, and I can sync from others. And with that, I thank you. We're getting close to lunch, so I will take some questions off to the side. But thank you again.